Hello everyone. Today's topic is Stokes theorem. This is one of the theorem from vector integral theorems. So this theorem is for transformation between line integral and surface integral. Going to the formula for the Stokes theorem is let S be a open surface bounded by a closed non-intersecting curve C. Here we are taking the surface is open and it is non-intersecting curve, means it's a simple connected curve, so that is called C. If f bar is any differentiable vector point function, then integral closed integral over C f bar dot dr bar is equal to integral over S curl f bar dot n bar ds. This theorem is for transformation between line integral and the surface integral. Here integral over S curl f bar dot n bar ds is a surface integration, and integral over C f bar dot dr bar is a line integration. So where C is in anti-clockwise direction and n bar is the unit outward drawn normal at any point of the surface. Next example for the Stokes theorem is, so verify Stokes theorem for f bar is equal to 2x minus y I bar minus yz square j bar minus y square z k bar over the upper half of the surface of the sphere x square plus y square plus z square is equal to 1 bounded by the projection of the xy plane. So here the given surface is upper half of the sphere. The sphere equation is x square plus y square plus z square is equal to 1. So that's why the radius of the sphere is 1. R square is equal to 1 here. So that's why R value is 1. And the given vector is f bar. By using these two, then we can verify the Stokes theorem. Verify the Stokes theorem means you need to find the LHS, means line integration value, and RHS, that is surface integration value for the f bar. You can find it that both values are equal, then you can finish the verification of Stokes theorem. So first we have to start with a line integration. First write the Stokes theorem formula: integral over C f bar dot dr bar is equal to integral over S curl f bar dot n bar ds. So first find f bar dot dr bar. So here f bar is 2x minus y I bar minus yz square j bar minus y square z k bar into dr bar is dx I bar plus dy j bar plus dz k bar. Multiply both, we get 2x minus y into dx minus yz square into dy minus y square z into dx. Because of I bar dot I bar is 1, so that's why we multiply only the coefficients of I bar and j bar and k bar. I bar dot I bar is 1, k bar dot k bar is also 1. So that's why we can multiply only I bar, j bar, k bar coefficients. Next, where S is a circle in xy plane, given surface is a circle in the xy plane, because of we are considering only upper half of the sphere, means that if you take one ball, that is the shape of the sphere, cut into half part, the base is a circle. So if you keep in xy plane, then we consider our surface is as a circle. X square plus y square is equal to 1, because of in the xy plane z0. So z0 means dz is also 0. And going to the f bar dot dr bar value from z equal to 0 and dz is equal to 0, we get 2x minus y into dx, because of dz 0, third term 0, and z 0, so that's why second term also 0 from f bar dot dr bar. So we get only f bar dot dr bar is equal to 2x minus y into dx. Now find the integral over C f bar dot dr bar equal to substitute integral over C f bar dot dr bar value 2x minus y into dx. Here we can change into polar coordinates, easy to get the integration, because of polar coordinates means it is a parametric equation in theta. So that's why you can take only theta limits. It is a line integration. We have a possibility for only single integration. So that's why our equations change into parametric form of theta, that is substituting x is equal to r cos theta. Here r value is 1, so that's why cos theta. Y is equal to r sin theta, that is r value 1, so it's sin theta. Find dx. Dx is equal to cos theta, derivative is minus sin theta, theta derivative is d theta. And going to the limits for the theta. So here our surface is in the circle shape. Circle limits for the theta is 0 to 2 pi, because of it is a 360 degrees. Start at 0 and at 360. So that's why in limits are 0 to 2 pi. So now integral 0 to 2 pi, substitute the values for x and y dx also. So 2 into cos theta minus sin theta into dx value is minus sin theta d theta. Then minus integral 0 to 2 pi 2 sin theta cos theta, multiply with sin theta. So that's why 2 sin theta cos theta minus sin theta into sin theta is sin square theta into d theta. So minus integral 0 to 2 pi sin 2 theta, because of 2 sin theta cos theta value is sin 2 theta d theta, and minus multiply with this minus, we get minus into minus plus integral 0 to 2 pi sin square formula 1 minus cos 2 theta by 2 into d theta. Separating the integrations with two terms, that is first sin 2 theta integration is minus cos 2 theta by 2, then limits are 0 to 2 pi plus 1 by 2 is constant right outside, and integral d theta is theta minus cos 2 theta integration is sin 2 theta by 2, limits are 0 to 2 pi. Next one, substitute the limits, we get here 1 by 2 cos 4 pi minus cos 0 plus 1 by 2 2 pi minus 1 by 2 sin 4 pi minus sin 0. So here we have cos 4 pi value is 1 and cos 0 value also 1. 1 minus 1 0, and here 1 by 2 into 2 pi minus 1 by 2 into cos 4 pi value 0 sin 0 value 0. So that's why we get only 1 by 2 into 1 minus 1 0. So this value also 0. 1 by 2 into 2 pi. Then we can get 2 cancel pi. Integral CF bar dot dr bar value is pi. So now evaluate integral over s curl f bar dot n bar ds is equal to, yes, surface integration we find by using the double integrations. That's why double integral over s del cross f curl f bar means del cross f bar dot n bar ds. So first find the curl f bar. Del cross f bar is equal to determinant of I bar, j bar, k bar, dou by dou x, dou by dou y, dou by dou z. Here f1 is 2x minus y, f2 is minus yz square, f3 is minus y square z. So next find the determinant by using the first row I bar into dou by dou y of minus y square z, dou by dou z of minus yz square. Next term minus j bar into, you can eliminate first row and second column, dou by dou x of minus y square z, dou by dou z of minus 2x minus y. Next term plus k bar, eliminating first row last column, remaining 4 terms determinant, that is dou by dou x of minus yz square. Next minus dou by dou y of 2x minus y. Next find the partial derivatives. All of you know the partial derivative with respect to x, y, z. If you find the partial derivative with respect to x, y, z are constants. Find partial derivative with respect to y, x, z are constants. And partial derivative with respect to z means x and y are constants. By using that rules, find the partial derivatives, that is I bar into dou by dou y of minus y square z. Here minus z is constant, y square derivative is 2y minus 2yz plus y we write plus, here minus into minus is plus, and z square derivative is 2z, 2yz plus 2yz. Next term minus j bar into dou by dou x of y square z derivative 0. There is no x term, these two are constants, so that's why 0. Next minus dou by dou z of 2x minus y, derivative also 0. X and y are constants, so that's why it is 0. So plus k bar dou by dou x of minus y z square. So minus y z square with respect to x, so that is also 0. Next to dou by dou y of 2x minus y. So here y derivative is 1, negative sign is there, minus 1, minus of minus plus 1. So we get curl of bar value is k bar. Then substitute in the formula, we get k bar dot n bar ds, but here ds is equal to dx dy by modulus of k bar dot n bar. So what how to write this one? We can write this by using the projection of xy plane. So projection of xy plane, ds is equal to dx dy by modulus of k bar dot n bar is a formula from the surface integration. By using this formula, we write projection of s on xy plane is considered as a r. So that's why we can write double integral over r k bar dot n bar dx dy by k bar dot n bar. K bar dot n bar is a positive value because of it is a modulus value. So that's why cancel both, we get dx dy. Here we have another possibility, right, for substitute n bar is equal to k bar because of the projection is in the xy plane. Projection in the xy plane means the outward drawn normal vector n bar is equal to k bar. Directly we can consider n bar is equal to k bar because of the projection is outward drawn normal. N bar is outward drawn normal. Outward drawn normal means it is considered as a z plane, means z plane n bar is k bar. So that's why we can directly write as n bar is equal to k bar. K bar dot k bar is 1. Directly we can take ds is equal to dx into dy. Otherwise we can use the projection. Directly we can write the formula ds is equal to dx dy by modulus of k bar dot n bar. We have two procedures to solve k bar dot n bar or projection of s. So here we are using the projection of s, so that's why we are writing dx dy by k bar dot n bar. Simply both are cancel. R is the projection of s and r is x square plus y square is equal to 1 because of our region is in xy plane and the equation is x square plus y square is equal to 1. So here x limits, total complete circle. So complete circle means the limits for the x are minus 1 to x limits are minus 1 to plus 1 because of the radius is 1, minus 1 to plus 1, and the y limits are y is equal to minus under root of, from this equation you can write y square is equal to 1 minus x square, y is equal to under root of 1 minus x square. So that's why y is equal to minus under root of 1 minus x square to y is equal to under root of 1 minus x square. So by using that limits we find the integration. And also here we have another possibility to write the limits for 0 multiplying with 4, means that here x limits are minus 1 to 1, then you can multiply with 2, you can change into 0. Here also y is equal to minus under root of 1 minus x square to root 1 minus x square. So that's why you can change the limits to 0 by multiplying with 2. So 2 into 2, 4. Directly you can write 4 into integral x is equal to 0 to 1, integral y is equal to 0 to under root of 1 minus x square dx dy. So 4 into integral x is equal to 0 to 1, integral dy is y, limits are 0 to under root of 1 minus x square dx. So 4 into integral x is equal to 0 to 1. So substitute the limits, we get under root of 1 minus x square dx. So formula is integral under root of a square minus x square dx is equal to x by 2 under root of a square minus x square plus a square by 2 sin inverse of x by a. A is equal to 1 here. So that's why we can substitute it x by 2 under root of 1 minus x square plus 1 by 2 sin inverse of x by 1. Because of here a square is equal to 1, a value is 1. So that's why we can substitute 1 by 2 sin inverse of x by 1. So then you can substitute the upper limit and lower limits. We get first upper limit, first value is 0 because of x value is 1, 1 minus 1, 0, plus 1 by 2 sine inverse of 1 by 1 sine inverse of 1, minus lower limit is x value 0 means this total value is 0 and sine inverse of 0 means 0. So we get only 4 into 1 by 2 sine inverse of 1 value is pi by 2. So substitute it, we get 4 into pi by 4, 4, cancel, we get the pi. From equation 1 and 2, we can write integral C f bar dot dr bar. Already line integration value is pi, and surface integration of curl f bar dot n bar ds value also we get pi. So that's why the Stokes theorem is verified from both the equations, equation 1 and equation 2.